Good morning, Trig students. I am sorry that I'm not going to be able to be with you there today. I have to stay home with a family member today. So I'm going to leave you some videos to watch for today's lesson, and then you'll have some problems to work on tonight, and I've left you an answer key for this also. All right, so I want you to start out actually playing around with this little exploration for just a moment. Let me explain it to you, and then I want you to turn off the video, try it on your own for a moment or so, and then turn the video back on, and I'll kind of talk to you about it. So the problem says, is the following statement a trigonometric identity? So remember that a trigonometric identity means a statement that's true no matter what you put in for alpha and beta. So if you're going to explore whether it's correct or not, then what you would want to do is pick a couple of angles, call them A and B, and then sub those in here. And then you can use your calculator if you want. Use the cosine button. You can be in either radians or degrees, whatever you want to pick your angles to be in. And just check to see, is the cosine of the sum of two angles the same as the sum of the two cosines? So turn off the video for just a moment. Why don't you explore that? All right, so if you are back, I'm assuming that you've explored this problem on your own. Excuse me, and hopefully you found that the answer to this is no, it is not a trig identity. And if we're going to prove that a statement is false, then all we have to do is find one example where it doesn't work. So my example that I'll show you is, for example, if we let A equal 90 degrees and we let B equal 30 degrees, then over here we would have the cosine of the quantity 90 plus 30. And we're trying to figure out, is that equal to the cosine of 90 plus the cosine of 30? And for this one, actually, we're not even going to need our calculators because we can find all of these trig values on our own. So this becomes the cosine of 120 degrees because the order of operation says you add those first. And then over here, this is the same, cosine 90 plus cosine 30. Okay, so the cosine of 120 degrees, if you go to your unit circle, you'll see that that's negative 1/2. The cosine of 90 is 0. Again, we're trying to figure out if these are equal. And then the cosine of 30 degrees is the square root of 3 over 2. And you can clearly see that those are not equal to each other. So because we're able to find at least one example where it doesn't work, it's not an identity. Now, it's possible that you might find something that does work. And if you think that it does work for that one pair, then you would want to try it for another pair, and maybe for another pair, and then eventually you would want to write a proof that that pattern is correct. But we found what's called a counterexample, so it does not work. So the reason that I put this up here is because it's so tempting to say that there's a distributive property of cosine. In other words, that I can kind of distribute the cosine to A and B and get cosine A plus cosine B, just like you would do, 2 times x plus 3 and say 2x plus 2, 3. But remember, this is not multiplication, all right? This is not cosine times A plus B. It's the cosine of A plus B. It's something different, all right? Cosine is more involved. It's a ratio of some kind. And so it just doesn't work. It's not a distributive property. So what are the properties? So what I have listed here are all of the formulas, and when I get back tomorrow, we may go through a proof of at least one of these and kind of talk about right here. I said in class we'll explore the derivations of these identities, but I'm not going to do that in today's videos. So here are the formulas. So you can see they're a little bit complicated, little involved. And I will teach you tomorrow a little mnemonic device to help you remember them. They are also on your formula packet, so you don't have to have these memorized. But you'll notice that if you have the cosine of the quantity A plus B, so the cosine of the sum of two angles, then the formula goes like this. It goes cosine of the first one times the cosine of the second one, and then minus the sine of the first one times the sine of the second one. And then you'll notice conveniently that the formula for the cosine of the difference of two angles, in other words, if you're subtracting two angles and you need to simplify it, then it's the cosine of the first one times the cosine of the second one. So notice that this part's the same, so that's kind of nice. and then it's plus, and then it's the sine of the first one times the sine of the second one. So again, you'll notice that this is the same as this, so it makes it a little bit easier to remember. So for the cosine ones, if you're trying to remember the order of what you do, first of all, notice that in this first column all the way down, it's A, and then in this column all the way down, it's B, this column all the way down, it's A, this column all the way down, it's B. But notice that this is cosine times cosine, sine times sine, cosine times cosine, sine times sine. And then notice that in cosine, if this is a plus, then this is a minus. And if this is a minus, then this is a plus. All right, then for the sine, you'll notice that they also kind of conveniently go together. So the pattern for the sine is it's the sine of the first one times the cosine of the second one, plus the cosine of the first one times the sine of the second. So it's sine times cosine and then cosine times sine. And then over here, it's the same thing. Sine times cosine, sine A, cosine B. And then over here, the same, cosine A, sine B, cosine A, sine B. On this one, notice that the signs are the same. All right, for the sine, it's sine, it's plus, and then it's plus. For sine here, it's minus, and then it's minus. All right, and then for tangent, again, notice that they kind of go together, and these two are fractions. And this comes from, again, we'll talk about the derivation, but the reason that tangent is fractions is remember that tangent is sine theta over cosine theta. And so what we'll do when we want to find what the tangent of alpha plus beta or a plus b is we'll make it the sine of a plus b over the cosine of a plus b, and then we'll use the formulas from up above and simplify it. So anyway, when you finish simplifying it, the tangent of a plus b turns out to be tangent a plus tangent b over 1 minus tangent a times tangent b. And then notice for the tangent of a minus b, it's very, very similar. It's just the signs change. Signs meaning S-I-G-N. Excuse me. So the tangent of a plus b, notice there's a plus here, so there's a plus here, and then there's a minus on the bottom, and then there's a minus here, there's a minus here on the top, and then a plus on the bottom. So the one on the top matches what's here, and then the one on the bottom is the opposite. Again, this matches this, and the one on the bottom is the opposite. So those are the formulas. Again, we'll talk tomorrow if we have a chance about where those come from a little bit more, but today I'm just going to take you through some videos to use them.